Hello friends, I welcome you in lecture number 6 on graph theory. In this lecture we will understand these definitions, in degree and out degrees of directed graph. We have understood the definition of degree of a vertex in an undirected graph, and we know that degree of a vertex in an undirected graph is the number of edges incident with that vertex, or number of edges meeting or ending at that vertex is called the degree of the vertex in an undirected graph. But in directed graph we have directed edges, so we have in degree and out degree for each vertex. For example, suppose I consider this directed graph, and suppose these are the edges of this directed graph, and suppose we denote these vertices by v1, v2, v3 and v4. So first we define in degree of a vertex. So suppose we want to find out in degree of this vertex, then we have to determine the number of edges which are going to this vertex, or the number of edges whose terminal vertex is v1. So here we can see that this edge is having terminal vertex as v1, this edge is also having terminal vertex as v1, or we can say that there are two directed edges ending at vertex v1, or there are two directed edges going to vertex v1. Therefore in degree of vertex v1 is 2, and for in degree we will write negative sign above this notation. So this is the notation for in degree. In degree of vertex v1 is 2 because there are two edges whose terminal vertex is v1, or because there are two edges ending at v1, or because there are two edges going towards v1. Similarly, we can talk about out degree. Out degree means the number of edges whose initial vertex is v1, or number of edges which are going out of v1. So here is one edge which is going out of v1, or the edge whose initial vertex is v1, or the edge beginning at v1. So the number of edges whose initial vertex is given vertex is called the out degree of that vertex. So here there is only one edge which is going out of v1, therefore out degree of v1 is 1. So in this way we can determine the in degree and out degree. Suppose we are interested in the in degree of vertex v2, then we have to determine the edges which are going into the vertex v2. So here there is no edge which is going into vertex v2, or there is no edge whose terminal vertex is v2, therefore in degree of v2 is 0. And suppose we are interested in the out degree of v2, then we have to determine the number of edges going out of vertex v2, or number of edges beginning at v2, or number of edges whose initial vertex is v2. So there are two edges which are going out of v2, therefore out degree of v2 is 2. And suppose we want to write in degree of vertex v3, then we can see two edges are there which are going to v3, therefore in degree of v3 is 2, and there is no edge which is going out of vertex v3, therefore out degree of vertex v3 is 0. For v4, for in degree we have to determine the number of edges going towards v4, but there is no edge which is going to v4, therefore in degree of v4 is 0, and out degree of v4 is 1 because there is only one edge which is going out of v4. So this is the meaning of in degree and out degree of a vertex in a directed graph. They can ask you to write down the definition. So I have written here, in a directed graph, the in degree of a vertex v, denoted by this notation, is the number of edges with v as their terminal vertex. That is, suppose we have this vertex v, and if there are 3 edges whose terminal vertex is v1, that is, they are going towards v1, then in degree of vertex v is 3. In degree of a vertex v is the number of edges with v as their terminal vertex, or the number of edges which are going to vertex v is called the in degree of vertex v. And similarly, out degree of vertex v is the number of edges with v as their terminal vertex. For example, if I have this type of situation, then there are 2 edges whose initial vertex is v, so the out degree of vertex v is equal to 2, the number of edges with v as their initial vertex. If we have a loop in a diagram, then loop contributes 1 to both the in degree and the out degree of that vertex. For example, suppose I have a loop here, then loop is the direct edge whose initial and starting points are same. Therefore, if there is a loop at a vertex v, then we will consider in degree of vertex as 1 and out degree of vertex is also 1. We can write this definition in 2 different ways also. In a directed graph, the in degree of a vertex v is the number of edges ending at v. The number of edges which are ending at vertex v are those edges whose terminal vertex is v. So instead of writing in this way, we can write that in degree is the number of edges ending at v, and similarly out degree of a vertex v is the number of edges beginning at v. Equivalently, we can write in this way also. In a directed graph, the in degree of a vertex v is the number of edges that go to v, that is, this direction points toward the vertex v. So we can say that these 2 edges e1 and e2 go to vertex v, and the out degree of a vertex v is the number of edges that go out of v. So in this type of situation, we have vertex v as the initial vertex of these 2, and we can see these 2 edges are going out of this vertex v. Here I have taken one graph. Find the in degree and out degree of each vertex in the graph. So we can again write here for each vertex. Sometimes they ask you to write down in degree and out degree of each vertex in a given graph. So we start with vertex A. This is vertex A. For in degree, we have to determine the number of edges that go to vertex A. So this is going out of vertex A, this is also going out, this is also going out, this is going to vertex A. So there is one contribution here, and there is a loop at vertex A, and we know that loop at a vertex contributes 1 to both in degree and out degree. So therefore in degree of vertex A is 2. There are 2 edges which are going to A, or there are 2 edges whose terminal vertex is A. For out degree, we have to determine the edges which are going out of A. So this is one edge which is going out of A, this is another edge going out of A, 1, 2, then 3, and loop also contributes, so we write 4 here. The number of edges going out of A are 1, 2, 3 and 1 loop, that is 4. Now we write for in degree of vertex B. For in degree we have to find the number of edges which are going to vertex B. So this is going to vertex B, this is another edge going to vertex B. So there are only 2 edges going to vertex B. For out degree we have to determine the edge going out of B, and there is only one edge, so out degree of B is 1. For in degree of vertex C, first we consider loop, that is 1, then this is going to vertex C, so another contribution of this, and this is also going to vertex C, so there is another contribution. This is going out of C, so in degree of vertex C is 3. For out degree we have to determine the edge going out of C, so this is the only edge going out of C, remaining are going inside, and there is one loop, so 1 plus 1, 2. For vertex D, this edge is pointing towards D, so 1 is for in degree, this is going out of D, this is going towards D, so we have to count this edge. This is going out of D, that is in degree of D is 2. For out degree we have to determine the edges going out of D, so this is one edge going out of D, and this is also going out of D, so 1 plus 1, 2, and these two are pointing towards D, so out degree of D is 2. For vertex E, first we count the in degrees, so there is a loop, so we write 1 for loop, and this is pointing towards E, so it will contribute 1 to the in degree. This is also pointing towards E, so that is also contributing 1. So this is 1 which is going to E, this is another going to E, and there is one loop, so 3 here. And for out degree we have to count the edges going out of E, so this is 1, let me write here, this is another 2 which is going out of E, this is not going out of E, and for loop, so there are 3. And we can see this vertex F is isolated vertex, so there is no edge which is going to F and going out of F, therefore in degree and out degree of vertex F are 0. So it is very easy to count the in degree and out degree of each vertex in the following graph. So this is all about this session. Here we have understood how to count the in degree and out degrees of a vertex in a directed graph. Thanks for watching.